I'll be talking about just how we go about sampling our manure and wastewater. And if you actually look at the recommendations, those numbers vary all across the board. But first, we'll start just at the beginning. Why would we want to sample our manure and wastewater? We really want to do that because we're trying to make sure that we utilize those nutrients in a very beneficial and environmentally friendly manner. And we don't want to be degrading our water quality or leading to a lot of algae growth, et cetera. We also, in many cases, our producers need those to do nutrient or manure samples for their nutrient management plan to verify and document that they are utilizing those nutrients correctly. Now you might be wondering, well, why don't we just use book values? ASABE, NRCS, they have some great book values. And so it's like, well, why don't I just use those? I wouldn't have to go out there and go try and crawl around on the edge banks of the lagoon or try and wade through a manure pile to try and get stuff. And the reason is that those book values are really good starting points, but they don't necessarily represent your farm at all. Oftentimes those values are off by 50% or more. There's quite a few cases where they've looked at it, and individual farms may be off by 300% or more. So using a book value is probably not going to represent what your farm has. It's a great place to start, but you really need to do some of that sampling to fine tune that. The reason those nutrients vary by farm, the animal species definitely has a factor in it, but the diet and feed efficiency, that manure, the characteristics of that are going to vary tremendously based on how much water you use and how you handle that, the amount of bedding, your manure management practices. Are you separating the manure? Are you keeping it covered? How do you store it? Is it stored outside? Is it pretty well protected? How long is it sitting out there? All of those things can greatly impact the nutrients in our manure. So when should we sample? And the obvious answer is that we really want to sample as close to application time as possible. And that's really true for the manure because the manure breaks down much more rapidly than like compost. And so we have those microbes breaking down the ammonium, the organic matter, the volatile organic carbons are definitely breaking down. And we really have two options when we're looking at sampling. We can sample prior to application with the goal of trying to get those results back in time to dictate how much manure we should apply on that application, or as becoming more and more recommended, at least for those operations that already have several samples done over previous years, sampling at the time of application actually probably gets us some better results as far as how well it represents the manure that's out there. And so here's just a table kind of looking at it. So sampling prior to application, you get to use those results for that manure at that time. So there's no guessing, no misunderstanding as to how much is there. The problem with that is that it's really hard in many cases to get a good uniform sample, which means that your results may or may not be as accurate as you want. It's oftentimes much more difficult to sample prior to application. It's usually more time consuming, and you may need some additional special equipment. And in the case of confined pits, it's actually fairly dangerous to try to get some of those, or can be. If we sample during the application rate, it's much easier, it's faster. The drawback is that we don't have those results for that application. So sampling during application really works the best for like those farms where you are getting a manure sample every year and you kind of have a bit of a track record and know where you're starting at. So where do we start? First, we need to realize that our manure is in different forms. We have solid manure is considered anything with more than 20% solids. That is the manure that will actually stack and stay there. Semi-solids between 10 and 20%, it'll kind of stack, but it kind of doesn't stay piled very high, kind of gets kind of soggy at the bottom. Slurries are really thick, treated as liquids, but they're 4 to 10% solids. We usually have to have special pumping equipment, chopper pumps and things like that to make it work. And then our true liquid is like our Lagoon effluent. That's liquid with less than 4% solids. We are going to want to identify our sampling methods. So there's usually different approaches to it or different ways you can get some of those samples. So you're going to want to figure that out. You are going to want to identify your testing lab ahead of time. We really, really recommend that you use a certified lab, such as like the NAPT certification, the North America Proficiency Testing, but you want to be sending your samples to a lab that you know is actually giving you good results. If you don't really want to be sending them to a lab that's just trying to sell you fertilizer and you don't know that their results are accurate. You're going to want to make sure that they can do the analyses that you want. You're going to want to check and see what size sample they require. Different labs can have different requirements for that. If you are sampling prior to application, you are definitely going to want to know the turnaround times. Will you have your results in a week or two, or is that more like a month or 6 weeks? Because you want to sample as close to application time as possible, you want to know how far in advance you need to send that sample in. You'll want to check on what kind of containers they want you to send the samples in and the costs. You're also then going to want to start to collect the materials that you need to collect your samples. So in many cases, that's just a shovel and some buckets, and then either your bottles or freezer bags for those samples. But in certain cases, you have more complex equipment that's needed. You also are going to need to have a way to keep that sample cool. That manure will degrade and those microbes will start breaking it down. You'll get a lot of gas production, which can create problems if that sample gets warm. So we need to be able to keep that sample cool. So if you're out there all day collecting samples, you're going to need a way to keep it cool during the day. So let's look at our guidelines for solid manure. This is probably the most common. Most people have some solid manure piles. Our little hobby farms have solid manure piles. And so sampling from a manure stockpile is very common. It's also probably one of the ones that is the hardest to get a really good sample for. There's a lot of variability in a manure stockpile. It's typically outside, so you get a lot of weathering. And if you don't get a good representative sample, then your results are off and you're not likely to get the data that you need. So if you look at this little sketch of a manure pile, the outside has a dry surface, a skin or a crust. You don't want to sample in that. That helps hold some of that moisture in. The middle of the pile is kind of in the middle for the moisture. And then a lot of the liquid kind of sits at the bottom. And you'll note in this diagram how that nitrogen content can vary based on where it is at in that pile. So if you're only sampling down at the bottom, your results are going to say that you don't have nearly as much nitrogen and you have a whole lot of moisture. So it's really important to get a good representative sample. So how do we do that? In a manure stockpile, it's really important that we get a lot of samples, and the more diverse that stockpile is, the more samples that you really need to have to get a good representative sample. They recommend between 10 and 20 samples. One study actually showed that even at 20 samples, it's really easy to not get good representative samples. So you need to be looking at what you're doing and try to avoid areas that aren't representative of the pile. You don't want to just go along the little front edge and get the ones that are easy. You need to go all the way around the pile. Don't forget to get into the center of the pile, but you're trying to get a good representative sample. So from that stockpile, you're going to have your 10 to 20 widely dispersed sites. You're going to go all the way across that pile. You're going to try to take from areas where the material is representative of that pile. So if you have just a little cluster of bedding that's just looks like it's just bedding, you're going to want to avoid that. You want to get what looks like it's that entire pile. You're going to want to look for areas that the moisture content appears to be fairly representative. You're going to want to remove that crust. We don't want to sample that dry exterior. And then you're going to want to go at least 18 inches. And ideally, you're going to have some samples that are going deeper into that pile. And so from each of those sites, you're going to collect a subsample from that pile. You can use a spade or a manure collection probe. Some people have augers on drills that they use. You're then going to take those samples, put them in a clean plastic bucket, or you can put them in a wheelbarrow, you can put them on a tarp, put them on a piece of plywood, whatever system you have for where you put those subsamples. You're then going to need to mix it really thoroughly, because that's part of it. You need to get a good mixture of that so that you aren't selectively grabbing unrepresentative parts. And then you take your composite sample. In the case of manure, we typically put it in a freezer bag. They recommend filling that about 2/3 full so that there's plenty of room for expansion, either if you're freezing it or for gas production. Remove any excess air, seal it, double bag it. Nobody wants those breaking as it's being transported, and then keep it cool. If we're doing our sampling when we're loading it, and that actually is preferred, and you'll note that they drop down those recommendations from 10 to 20 to 10 to 12 subsamples because you're getting some mixing as you're loading it. One of the key things there is that they recommend that you get samples at the beginning, the middle, and the end of that load out process. Again, same system, take some subsamples, put them in a bucket or wheelbarrow, mix them well, take your subsample and fill your bag.
As a sample.
And if you want to check your solid manure when you're spreading it, you can actually test the manure for the nutrient contents as you're spreading it, and actually even double up and test the application rate, how well your manure spreader is calibrated. But you do that by putting tarps out across the field. If it's a really big field, you're not going to have them all in one little spot. You're going to have them spread out in different locations. The spreader goes across it, you gather the tarps, put all the manure into the middle, break apart any clumps, mix it really well, and then take 1 to 3 subsamples per tarp, put those in a clean bucket, mix it well again, and take your composite lab sample. Now, poultry, I know we don't have that many poultry operations in Utah, but some. But if we're doing poultry, it used to always be that it was recommended that you would sample the litter while it's still in the house. Now they're actually starting to recommend that it's actually better to wait until you do the clean out at the end in between. So you do several flocks, and then every so often you'll take all of that bedding out and you'll start all over. That's actually the preferred method now. But there are 2 different methods for if you want to sample while it's in the house. It is fairly time consuming and labor intensive, and it's difficult to get good samples. But those are the point and trench method. The point method, you're going to divide your house into 3 zones, and then you're going to basically walk a little zigzag path, and you're going to identify 8 to 10 spots along that path. You're going to take a little shovel, flat nosed shovel or spade, and dig down, creating a little trench. And then you're actually going to take a little 1-inch slice off the edge of that trench and put that into the bucket. And you're going to do that at each of those spots in each of those zones. So you would end up with 24 to 30 subsamples that go into your bucket. And then you're going to mix those. One of the things you really need to note is that you do need to be trying to get a representative number of samples that are under the waterers and the feeders, because the nutrients under those areas are different than the rest of the house. The trench method is another method, and it's really just probably kind of an interesting method. You divide the building into 2 areas, the brooder area and the non-brooder area, and then you start in the middle and you dig a trench all the way to the sidewall, and you just a narrow little trench, and then all of that litter in that trench goes into a wheelbarrow. Now you'll probably fill up more than 1 wheelbarrow. So what they recommend, and this is an approach you can use in other settings, so like your solid manure piles, if you run out of room, this is an approach you can use. But when your wheelbarrow is 2/3 full, you mix it really well, break up any clumps, remove 1 shovelful and put it into a bucket, empty that wheelbarrow near the trench, and keep going through it till you've gotten all of the litter in that little trench all the way across. And then you take those little subsamples that you've put into the bucket, mix those well, and obtain your lab sample. Sampling at Cleanout is actually the preferred method, and the real reason for that is because the litter in the house varies quite a bit. If you wait till you get to Cleanout, you're already getting a lot of the mixing, and so it's easier to get a representative sample. And so it's just like solid manure. You go to that pile, you take 10 to 20 subsamples, making sure you sample from the entire pile, mix those in a bucket, and take this composite sample to the lab. For compost, again, compost is really just like our solid manure, except it's already been mixed a lot. And so 5 to 8 subsamples is more than adequate on compost. And so again, you want to make sure you're sampling from the entire pile. So if your manure changed as you were putting it into a row for that compost, that you can account for that. But you're just going to go through, grab some little subsamples, mix them in a bucket, and take that, send a sample to the lab. Liquid manure, our wastewater or our lagoon water, has its own little unique oddities. So the lagoons are the less than 4% solids. As that water and those solids sit in that lagoon, those solids start to separate. And so we have mostly clear water on the top, and we have the solids kind of getting more and more solids as you get to the bottom. And then there's a very bottom layer that becomes a sludge layer that's really just solids. The big thing out of this is that the nutrients also are stratified. So our nitrogen, 90% of that nitrogen is in that top liquid portion, the top 1 to 2 feet or so. And then, but the phosphorus is all pretty much with the actual solids particles way down at the bottom. So if what you really need to be doing is agitating your lagoon to help get a more representative sample. If you are not agitating, you really need to be accounting for where in that profile you are at, because those nutrients are going to differ tremendously. So typically the recommendations are always that you should always be agitating your lagoon before you sample at all. In a few cases, and I think this is primarily in the wetter states, but you may want to remove just a little bit of that water off the top. And so if you're only going to be taking a foot or two off and irrigating with that, sometimes people will not agitate it then, just because they're just trying to create a little bit more volume before they go and try and clean it clear out. If you're only removing that top portion, the top couple of feet in that lagoon, it's the same process as if you agitate it. In both cases, you're going to be trying to get samples that are at least 6 feet away from the bank. You're going to try and avoid any solids, debris, or scum. If there's a crust on your lagoon, some lagoons have crusts on them, you need to try and get that broken through and not shoved off to the side. But if you're sampling from a non-agitated lagoon where you're only taking off the first 1 or 2 feet, you only want to sample from about 1 foot below the surface. If you have agitated the lagoon, you're going to want to sample 3 to 4 feet below the surface. In both cases, you're going to get your 10 to 12 samples. You go around the lagoon and then transfer. In each case, you're going to take those samples, put them in a bucket, mix it really well, and realize that the solids will want to be dropping out right away as you quit swirling it. Some recommend using a plunger to mix it. Some use a ladle and say to get it into good swirling motion and then grab a ladle full as it's swirling. But make sure that you've got those particles suspended when you're taking your sample. Then transfer 1 pint to a composite plastic bottle or sample container. Make sure that it's a wide mouth bottle. So here's how we actually can sample in that lagoon. There's cup samplers, and you can make your own. You can take like the bottom of a 2-liter pop bottle, tie it onto a great big long pole, 10 to 15 foot pole or a PVC pipe, and go out there. Now in this case, in this picture, you'd want to be making sure that you're getting an area cleared from that debris and that scum on there, because you don't want to be sampling that. The other approach is to throw a bucket out there. And so you tie a rope onto a bucket, you throw it out towards the middle of the lagoon, and you let that bucket fall down. If you only want to sample out at the top foot or two, as soon as it hits the water, you start pulling it back. If you have agitated it, you're going to let it drop just a little bit. You want that bucket to be pulled through at about 3 to 4 feet below the soil surface. A little hint, you do want to make sure the bucket is raised before it strikes the bank, or you're not going to have your sample. And one thing you want to do is never ever use a galvanized bucket for any of these, because the galvanization process can interfere with the lab analyses. And oftentimes, more often than not, that lagoon water is being applied as irrigation water, oftentimes through a pivot or a sprinkler system. If you don't really want to go crawl around the lagoon for whatever one reason or another, you can sample it as it's being applied. The key there is that you're going to go take little either buckets or the aluminum foil roasting pans, and you're going to set them out in the field. You're going to let that irrigation system go over that, and then you're going to go collect the water from each of those containers, the buckets or the pans, put them in a bigger bucket, mix it, and get your sample. If you are doing that, one thing you should probably make sure that you are sampling at different times. So at the beginning of that irrigation process, in the middle as it's dropping down in the lagoon, and then again at the lower layers. And that's because even though we agitate those lagoons, it's hard to keep it really all in suspension, and especially if you stop it all, you're going to have solids settling out, and so that's going to change those nutrient profiles. And in the really large lagoons, it's almost impossible to get it agitated really well. And you can also do, if you have lagoon effluent that you want, you can sometimes, in some cases, people actually haul that out by truck or tanker or something like that. If you're doing that, you can absolutely sample it as you're loading it. That's actually probably the easiest. In that case, they recommend that you sample over the course of the pump out, so you get some samples that, well, you're at the top portion, the middle portion, and then the bottom, but it's the same exact process. Slurries. Now this is really, really common with our swine manure. The little bit heavier, thicker ones. The slurries, and so especially in the swine production, the solids still settle. They still stratify just like in a lagoon, and those nutrients also stratify. So it's really important that it's agitated if you want to, as you're applying it, to get a good sample. One thing in these, and for like a lot of the swine production, that manure is actually going into a pit underneath the barn. I cannot emphasize enough how careful you need to be if you are trying to be sampling from a pit underneath the barn, especially if you're agitating. So safety first. Those pits, that manure produces hydrogen sulfide, and hydrogen sulfide can be lethal. It smells like rotten eggs, so at first you can smell it, but the hydrogen sulfide can actually essentially deaden your little nerves that sense the smell, and so then you don't realize that that smell is still there. If you don't have adequate ventilation, you can succumb to that and die, and a lot of people have died when they're working in those confined pits. The recommendation is to always have 2 people present at all times. Never enter that pit without appropriate safety gear, such as a self-contained breathing apparatus. And the whole purpose of having 2 people there at all times is not for that second one to go rescue the first one. It's for that second one to go call the emergency people who can help you get them out safely. There are numerous cases of one family member succumbing. Someone goes to help them, they succumb, another family member, and they'll lose 3 or 4 family members all in one day trying to get somebody out of the confined pit. So be very careful on this. In your confined pit, agitated and non-agitated, again, you're going to want to collect 10 to 12 subsamples from different locations. Almost all of everybody suggests that you agitate it to get your really good sample. There are a few that say you can do this non-agitated. They're both using essentially the same type of device, a really narrow little PVC pipe, 1/2 inch to 3/4 inch in diameter, that fits in between the slats. And you're going and pushing that down in between the slats down to the bottom of that pit. And one system has a string and a little rubber ball that you pull onto it to help hold that slurry in that PVC pipe as you pull it up and then empty it into your bucket. The other one says make sure you go all the way down and then put your hand on top. So it's just kind of like a straw. When you put your finger on the top, how you can lift the liquid out, it's that same process. And so some will say you can do it when it's not agitated, but generally the recommendation is to agitate it. We also have slurries in outdoor holding ponds or above ground tanks. Again, they recommend that you mix it. They also use, again, a PVC pipe with like a little rubber ball at the bottom to take those samples. In this case, they usually use a bigger diameter, usually like a 2-inch diameter PVC pipe. But again, you're just going around the edge of that tank, getting your subsamples, putting them in a bucket, mixing it well, and putting that into your container to send to the lab. And you can, of course, sample slurry when you're loading it. So if you are hauling it out in tankers or wagons or something, it's very easy to get those samples while it's being loaded. You can have the little telescoping buckets, or you can have just a cup on the end of a big long pole, but it's easy typically to go get those samples. That's probably one of the easier ways to get it. Now, we've gotten our samples. Now what do we do with them? Sample handling liquids. It's the size that we typically need is 1 pint. You want to make sure that you've got your really representative sample that you were collecting while the solids were suspended. You're going to put that sample into a clean, wide mouth container. They do not want little narrow mouth containers at the lab. They want to have it be wide mouth so they can actually get all those little solids and stuff out of your container. It should be sealable and plastic. Never use glass. Please wipe off the outside of the container. They don't want all of that manure on the outside. The postman definitely doesn't. Make sure you label the sample. And again, we recommend that you only fill that container about 2/3 full so that you have room for any gas expansion or expansion if you freeze it. We do need to keep that sample cool or frozen, depending on when you can send that to the lab. For the solids, we need about 1/2 pound. That's about 1 to 2 pints in volume. You're going to take your sample and put it into a heavy duty sealable plastic bag. So a freezer bag, not the little thin sandwich bags, but the heavy duty plastic ones. You should really double bag it. Bags rip, and we don't want those ripping and spilling the contents all over. Label it with all the sample identification information that you need. Fill that bag only about 2/3 full. Again, keep it cool or frozen. And the key is noted, you should never be drying your solid manure sample. The lab will dry that, but they need to know how it was as you sampled it so that they can give you the as is basis, because you need to know what the dry matter percentage is, but so that as you're applying it, you get the right rates. And for shipping, it's recommended that you either ship immediately or refrigerator freeze the samples if you can't ship them immediately. If you're at the end of the week, you can't, don't put them in the mail on Saturday and have them sitting there. Ship at the beginning of the week so that you can make sure that that package is arriving at the lab during the week and not sitting in some mail room or out in some, mailbox somewhere. They recommend that you ship with no more than a 2-day delivery time. So you will want to make sure that if your mail service is really slow, you might want to make sure it's being shipped with 2-day mail, or put it in little coolers with little ice packs or something, but you want to make sure that stays cool, and then don't ship right before the holiday. And so that's really pretty much our guidelines for sampling manure and wastewater. It's